Welcome to Easy BTech channel. So in this module, we will see another type of binary codes known as gray codes. So gray code is a type of non-weighted code. So till now we have seen BCD code, which is nothing but 8421 and 2421 and 84 minus 2 minus 1. So these are all weighted codes. These are all weighted codes because each position is having a specific weight. So we have seen another code, XS3 code, which comes under non-weighted code. So this gray code also comes under non-weighted binary code. So where successive code words differ in only one bit. So this is the major difference between the codes which we have seen already and the gray code. So in gray code, so you take any two successive codes, words, they differ in only one bit. So that is the major advantage of gray code. So any code such satisfies this property, that means two successive code words differ in only one bit, are known as cyclic codes. They are known as the cyclic code. So gray code is an example of a non-weighted code and it is also comes under cyclic codes, right? So gray codes, what are the advantages and applications of gray code is it is used in most of the practical applications. Gray codes are used in most of the practical applications like analog to digital conversion and digital communication. In digital communication, especially to reduce error while transmitting the binary data, to reduce the error in transmitting the binary data from transmitter to receiver. So that's why this is one of the most important code that everyone should know. And also the binary to gray and gray to binary conversion are also very easy. Unlike other codes, the circuit that is required to convert binary to gray and gray to binary is very easy, that we will see later, right? So how to obtain gray code? And gray code is also known as the self-reflecting code. It is also comes under self-reflecting code. It also comes under self-reflecting code. So why? Because if we have an m-bit gray code with us, right? So to obtain m plus 1 bit gray code, from m bit gray code, so first what we have to do, we have to write two m bit representation. We have to write two m-bit representation, one below the other. How we have to write means the second one being the mirror image of the first one. Second one we have to write the mirror image of the first m-bit gray code. So then what we have to do? So we have to add 0 at the beginning of every code in the first group, right? So here we are writing two m-bit gray codes, one below the other, the second one being the mirror image of the first m-bit gray code. So then what we have to do means we have to add 0 at the beginning of every code in the first group, and we have to add 1 at the beginning of the second group. We have to add 1 at the beginning of the, so for first m-bit gray code we have to add 0, to the second m-bit gray code we have to add 1, so that we will get m plus 1 bit gray code from the m bit gray code. So this we will see with the help of an example so that we can understand. So here we will see how to generate the gray code. For example, if you take 1 bit, so what are the possible with 1 bit? We'll have 0 and 1. Only these two possibilities we'll have. So now we have 1 bit gray code. So now we would like to get 2 bit gray code. Now how to get 2 bit gray code from 1 bit gray code? So now we have to take two 1 bit gray code. So this is the first half. The second 1 bit gray code, we have to take mirror image of the first 1 bit gray code, that means 1 0. Then the second step is we have to add 0 to the first group of 1 bit gray code, and to the second half of the 1 bit gray code we have to add 1. So this is the 2 bit gray code. This is how to generate the m plus 1 bit gray code from m bit. Similarly, the 3 bit gray code we will see how to get. So first we have to write the 2 bit gray code as it is: 0 0 0 1 1 1 1 0. Right now we have to take mirror image of this. We have to take mirror image of this 2 bit gray code. So 1 0 1 1 and 0 1 and 0 0. Right, so next, for the first 2 bit gray code, first half of the 2 bit gray code, we have to append 0. We have to append 0. For the next half of the 2 bit gray code, we have to append 1s. So this is how. So this represents 0, this represents 1, this represents 2, this represents 3, this represents 4, this represents 5, this represents 6, and this represents 7. For the decimal digit 0 to 7, so these are the 3 bit gray code. Similarly, to get the 4 bit gray code, to get the 4 bit gray code, so this entire set we have to write as it is here, and then we have to take mirror image of the 3 bit gray code, and then we have to append 0 to the first 3 bit gray code and 1s to the next 3 bit gray code. So that is why this is also called as the self reflection code. So this is also unit distance code. You take any 2 bits, you can observe here, you take any two successive codes, you take any two successive code words, they differ in only 1 bit. So for example, if you take 0001, so this MSP is as it is, whereas the LSP is changed from 0 to 1. Now if you take these two successive code words, these two successive code words, so you see this one, this LSP is as it is, but here this 0 is changed to 1. You take next two successive code words. Now these MSP bits are as it is, so the LSP is changed from 1 to 0. So any two successive code words you take in the gray code, they differ in only 1 bit position. So we can easily identify if any error occurs while transmitting from one place to another place. Similarly, you can observe in 3 bit gray code also. You take any two successive code words. For example, if you take 110 and 115, so these two positions are as it is, only the LSB is changed from 0 to 1, 0 to 1. Similarly, you take the last two code words, here 6 means 101 and 7 means 100. Again you see the significant, leftmost significant bits are 10, only the LSB is changed from 1 to 0. So that is why any two successive code words you take, they differ in only one position. So this is the important properties of the gray code. Next we will see how to convert a given binary. If a binary code is given to us, how to find the gray code, how to find the gray code. So for example, if we take an n bit gray code, so this is the n bit gray code, so gn-1, gn-2, z2, g1, z0, and this is the n bit gray code, bn-1, bn-2, and so on, b2, b1, b0. So how to obtain the corresponding gray code from the binary code means, so this is the MSB, this is the MSB. So MSB is same as the MSB of the binary, and next significant position. So this is how we will obtain BI modulo to BI plus 1. So where I is running from 0 to n minus 2. 0 to n minus 2. So this is how to obtain gray code from the given binary code modulo 2 operation we have to do. So this symbol indicates modulo 2 sum. So this is how it is defined. So if you add same two bits, if you add 0 modulo 0, it is 0, 1 modulo 1 is also 0. But if you do the modulo sum between two different bits, either 0 and 1 or 1 and 0, it will give you the 1. So this we will use while converting given binary to gray or gray to binary. So this is the procedure. If the code is in binary, how to obtain the gray code means the MSB bit we have to take as it is. So whereas the remaining positions we have to take modulo sum between two successive binary bits. We have to take modulo sum except the MSB. To obtain for the remaining positions, we have to take modulos to sum between two successive binary bits. So we'll see with the help of an example. So for example, if this is the given binary code, so this is the given binary code to us. We have to find how to find the gray code means we have to take the MSB bit as it is. So to find the gray code MSB bit we have to take as it is. Next we have to take the modulo sum between two successive. So if you take modulo sum between these two, modulo to sum between two bits, it will give the answer is 0. Next, to get the next position, we have to take modulo sum between two successive binary bits. If you take modulo sum between 1 and 0, it will give 1. Again, to get the next position we have to take modulo sum between 0 and 1. So 0 and 1, if you take modulo sum, it will give 1. Again, to get the next position we have to take modulo sum between the successive bits. Again, if you take modulo sum between 1 and 0, it will give 1. Again, if you take modulo sum between these two, it is 1. So if this is the binary code to us, the corresponding gray code is 101111. We'll take another example. So if this is the given binary number, for example 0 1 0 1 0 1 1. How to find the corresponding gray code means MSB we will write as it is. Next we will take modulo to sum between two successive binary bits. So 0 modulo 1 is 1. Again, for the next portion we have to take modulo sum between the two successive bits. So 1 modulo 0, it is again 1. Again, next, to get the next position we have to take modulo sum between two positions. So 0 modulo 1 is 1. Again, for the next position you take modulo sum between the two. 1 modulo 0 is 1. Again, for the next position take modulo sum between 0 and 1. So it is 1. So for the next one you take modulo sum between the next two positions. If you take the modulo sum between 1 and 1, the result is 0. So this is the for the given binary code 0 1 0 1 0 1 1. The corresponding gray code is 0 1 1 1 1 1 0. Right? So this is how to find the gray code for the given binary code. Next we will see another example. So here also this is explained. I will explain here. I will erase this with the help of the diagram. I will explain one more example. So if this is the given binary code 1010, if this is the given binary code 101101, so the MSB we will take as it is 1. So next bit we have to take modulo sum between these two positions. If we take modulo sum between 1 and 0, the result is 1. Right? So for the next position we have to take modulo sum between 0 and 1. 0 and 1, it is again 1. So for the next position we have to take modulo sum between 1 and 1. So the result is 0. Again, for the next portion we have to take modulo sum between 1 and 0, the result is 1. Again, for the next portion we take modulo sum between 0 and 1, the result is 1. So this is how to convert from binary to gray code. Right? So next we will see how to convert or how to get the binary code from gray code. How to convert the given binary code to gray code. So again, here We'll start with the leftmost bit, that is the MSB portion. MSB bit is as it is. MSB bit is as it is in both gray to binary and binary to gray code. The MSB bit as it is. Next, to get Bn minus 1, Bn minus 2, Bn minus 2, we'll take modulo 2 sum between Bn minus 1, Bn minus 1, Bn minus 1 and Gn minus 2. So whatever result we will get in the MSP position, so that we will do modulo sum between the next lower significant position Gn minus 2. So in this way we have to repeat for all the, to get the LSP whatever result we will get here in B1. So that we have to do modulo sum with the LSP of the given gray code, right? So this is the procedure how to find the binary code from the given gray code. So this also we'll see with the help of an example. So if this is the given gray code to us, if this is the given gray code to us, how to find the corresponding binary code? What we have said, so the MSP position is as it is, right? MSP position is as it is. Next we have to take modulo 2 sum between these two. If we take modulo 2 sum between, whatever result we will get, that we have to write here. So modulo 2 sum between 1 and 0 is 1. You can take modulo sum between these two and the result we have to write here. Modulo sum between 1 and 1 is 0. Take modulo sum between these two and write the result here. 0 modulo 1 is 1. Again take modulo sum between these two. 1 modulo 0 is 1. Again modulo sum between these two. Modulo sum between 1 and 1 is 0. So for the given gray code, the corresponding binary code is 110110. For example, if the gray code that is given to us is 0111110, what is the corresponding binary code? What is the corresponding binary code? So the MSP we have to write as it is 0, right? Next take modulo 2 sum between these two, modulo sum between these two. So 0 modulo 1 is 1, right? Again take modulo sum between these two and write the result here. Modulo 1 between two ones is 0. Now again write the modulo 2 sum between these two. 0 modulo 1 is 1. Again take modulo sum between these two. So the result 1 modulo 1 is 0. Again you take modulo sum between these two. What is the result? Result is 1. Again if you take modulo sum between these two, the result is 1. So for the given gray code, the corresponding binary code is 010101. So this is the binary code for the given gray code 0111110. The corresponding binary code is 010101. So in this way we have to find the corresponding binary code for the given gray code, right? So I will stop here. In the next module we will see one of the important concept, error detection and correction. So thank you for watching. I request everyone to subscribe EasyBTech channel and share to your friends. Thank you.